Good evening, everyone. My name is Sean Kelly, and I'd like to welcome you back to another Tech Talk in our series sponsored by CaseBlank. Today, I have the absolute pleasure of introducing Liam Donaher to give us a brief talk on network protocols. So, without further delay, I'd like to turn it over to you, Liam.
Thank you, Sean, for that warm welcome, and thank you, everybody, for coming out tonight. And thank you, CaseBlank, for sponsoring this Tech Talk. So today we'll be discussing everyone's favorite topic, network protocols. That's right. It's kind of an ambiguous name, but it's just a standard of how digital data is moved around. And today I'm going to try to demystify some of those standards for you. So there are a ton of networking protocols, and it would take hours to compare the differences between them all. And depending on the route your data takes from your computer, there might be a bunch of different protocols involved in just a single message. So really the only thing a protocol is just the format that a data is put in. So a computer can read it and send it to the right place. So for example, when you want to go to Google, your computer will send a request off to Google servers to tell them to send you back the code that displays the Google homepage. And the request to Google and the response will both be in an HTTP protocol format. But what does an HTTP request actually look like? Well, to your modem, an HTTP request is just a bunch of ones and zeros being sent off to your ISP. To the antenna of your Wi-Fi router, it's a bunch of just electromagnetic radiation. And tons of these messages are actually being continuously emitted by every device in your house. And you can actually see some of these messages right in the air if you have the correct software for it. So at the end of the presentation, I'll show you a way of intercepting this data and some fun things that you can do with it. But before that, if you'll indulge me, we're just going to check out how another similar system works, the post office. So this process, it seems really simple, but there's a lot of steps hidden behind the scenes, even for just something as simple as the mail system to make this work. So if you wanted to send, for example, your grandkid a present, you can't just put it directly into the mailbox. Maybe an obvious reason is it'll get damaged, so maybe you put it in a gift box. And this actually serves two purposes. It'll protect it, and it'll also tell the recipient that it is a gift and not just like a random Amazon delivery. Maybe the next obvious step is that you need to put this box in another box. I think you know where I'm going with this. We can just add all these other steps. There's a lot of pieces to this process. These are all things that you have to remember to do. You have to put your gift box in a bigger box, but this has to be a specific size, so it'll be accepted by the postal service. You have to add return address, destination, stamp to prove you pay for the service, all these other things. But there's also stuff that the recipient has to do. They have to have their own mailbox, and the entire postal service has to maintain certain things as well, like an address registry of everyone that's in the system. And this all could change depending on what service is doing the delivering, like FedEx, for example. All of these things are just built-in protections to make sure that the package arrives to the right place and in the right condition. So now we know how the postal system works. Network protocols are actually very similar, so let's get into that. So this is the anatomy of a network protocol, a very simple one. First, the layer, this first layer might be familiar to some of you. It's called the application layer, and it's just the body, headers, routes, queries, and parameters. Um, this request will look different depending on where in the internet you're sending it to, but this is just a basic example. In the case of many protocols, there may be some security steps before sending the data. Some messages are sent between a client and server to synchronize and then acknowledge each other, get certificates, encryption keys, and let each other know what the protocol versions the server are supporting. But the general format is that the data you want to send will be packaged up into a set of nested boxes or headers. So this application layer is the HTTP request that you're familiar with. Once the TCP header is added, the entire segment is converted into binary before going into the next layer's headers. So here are all the headers in the layer stack. So from top to bottom, we have the hardware layer, the internet layer, transport layer, and then the application layer. Each of these headers will be added on sequentially as the data is prepared for travel over the internet and then taken off in reverse when the data finally reaches its destination. So you can think of the data link layer as what postal services is picking up your package like FedEx or UPS. There's a different protocol associated with each piece of hardware the data has to go through, like Ethernet, Wi-Fi, or Bluetooth. The internet layer tells the data what the IP address it's going to. So this is very similar how you'd address a letter. If you're transporting data over the internet, you'll probably use some version of the internet protocol. IPv6 is the most recent one, but a lot of internet traffic is still using IPv4. Another kind of transport, well, this is the transport layer, and the TCP. The TCP is the biggest example of what is used in the transport layer. UDP is also used sometimes for DNS lookup, but this just tells what to do with a package once it gets to the front door. The final innermost layer is the application layer. This is where your data body, application type headers and stuff go. Some other examples are an FTP protocol for sending files, DNS, or WebSockets for live peer-to-peer connections. And now we're going to use one type of each of these protocols from each layer and construct exactly what a full request would look like. So first, we'll go through the data link or hardware layer, and this will tell the data how to move over the network hardware, in this case, through the Wi-Fi network. And here are all the pieces that go into that Wi-Fi 6 protocol. The body of the frame is where the other layers and the transmitted data will go. If the data is larger than this max size of 2,312 bytes, it'll be broken up into separate packets, and each will have their own layer stack associated with it. All of these other fields have specific purposes too, like this address field will contain the MAC address of the transmitting and the receiving devices. And this header actually comes with a piece that comes after the rest of the data, the frame check sequence. This is just 4 bytes, and this will just do some error checking on the whole message. And we're going to break each of these down into bite-sized pieces to show how much data is actually being transmitted. So each of these boxes is about 2 bytes. It's exactly 2 bytes, or 16 bits. That's like 16 ones or zeros in each of these boxes. So next is the internet layer. This is an example of IPv6, actually. IPv6 addresses are 128 bits versus IPv4, which is only 32 bits. And this can be thought of as just being added to the data link layer, although if you're sending a request out, this will be in reverse order. You'll start with the application, add on the transport, add on the internet, add on the data link layer. So next, the transport layer. This is the TCP protocol. You can see some of these are individual bits. This is a single bit. These flags do certain things. And this is added onto the data here, which is the application layer. In the application layer, this is just plain text. You can see this is a GET request to google.com. No body, just 3 headers. And this will be added to the transport layer header, in which case this will all be turned to binary, and the rest of these headers will be added as well as they go down the chain. So now we know how we got from our original text object and turned it into a binary signal, and that is getting beamed out from your computer in all directions, hopefully strong enough for your router to pick it up. But since the Wi-Fi signals are kind of going everywhere, they can be picked up by any device if you have the right software. So for example, you can read it with your own computer. This is something you can actually try at home. In fact, you shouldn't do it in public because it is illegal to read other people's data, but you need a computer, a network, and just some type of application to start a proxy server. There's a couple different ways you can do this. A common one is Wireshark. There's also Fiddler, and I think you can do it with Postman as well. I am going to use one called Charles Proxy though. So to start, you're going to need to connect your phone to this proxy. And then once you do that, you can make a request basically from any app to some service on the internet. So I'm doing Google Translate, and I'm translating library into Spanish. Google Translate got it correct. It's biblioteca. So once I did that, I can read that traffic in Charles Proxy. And there's actually going to be a lot of items showing up in this list, but right now I have it filtered to just this. There's some information you can see just from here. It's using the HTTP1 protocol. If it was using HTTP3, all of this would be encrypted as well, so I'd see no information about the message, but sometimes you just don't need to encrypt every single piece of data. You can also see, for example, the size of this request. But when I open up the actual body of the request, it's just encrypted mess. So now if I enable SSL proxying, which just gives my computer the keys to decrypt my iPhone's traffic, I can actually read what's in the body of that request. So you see a lot more information has popped up. I can see the post method, I can see the routes it's going to and all the headers. And now if I go to the actual body, I can read here is the actual text that was sent in the request body, and here's what was responded with from the server. And you might be thinking what I'm thinking, can I put both of these things directly into Postman? And the answer is yes. As long as you copy the headers and the body exactly, you can send a post request, not from your iPhone, but from a third party like Postman, send it to the Google API, and it'll give you the response back. So this is a pretty interesting way to see how other APIs are formatted. It also gives you a good debugging tool for your own network requests. And by sniffing the other requests sent by your phone or other smart devices, it's a good way to see documentation, or it's a good way to see how APIs are formatted if you can find the documentation online. And that's it. I hope the world of network protocols is now a little easier to understand. I think it's pretty interesting that all these protocols are still being updated to squeeze just a little bit more data into each request. And it's cool that even just a single bit can function as a flag or an error check. Taking a deep dive into these small details every now can be very rewarding as an engineer. I hope you found this informative. Here's a few references if you'd like to really read more. And if you have any questions or would like to talk to me directly about network protocols, you can send me an email, I guess, or connect with me on LinkedIn. I would like to thank CaseBlink one more time for sponsoring this Tech Talk, and thank you everybody for coming. And I will turn it back to you, Sean.
Thank you so much for that informative talk, Liam, and thank you everyone for coming out tonight. We'll see you at the next one.